Hello friends, welcome to IOQM lecture series. So we will be starting with final part of number theory part 12. So let us continue with the examples. Let n be the largest number that is product of exactly three distinct prime numbers. So n is largest integer such that it is product of exactly three distinct prime numbers, which are them d, e and 10d plus e. Okay, where d and e are single digit numbers. So d and e are single digit numbers. So we have to find such single digit numbers such that 10d plus e, it means the number de is a prime number as well. Okay, and it is product. So d into e into 10d plus e. This is what? Largest. Okay, what is the sum of digits of n? Okay, we have to find that. Now, what is the largest prime two-digit prime number? So let's see. We'll start from behind. So largest prime number is two-digit largest prime number is what? 97. Then, so 83. So let's just write it from the start. So 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47, 53, 59, 61, 67, 71, 73, 79, 83, 89, 97. So 97, 9 is not a prime. So this is cancelled, this is cancelled, this is cancelled. 73. Yes. 3 and 7 are prime. So our answer can be this. Okay. Now let us see more. So this is one option. And 67 is gone. 59. 53. 53 will be of course less than 73. So no point. Okay, this 47 is gone. Then 37 is also less than 73, so no point. Yeah, so this is our prime number. So what do we get? N is equal to 21 into 73. That is how much? 73 2s are 146. 73 1s are 73. So 3351. So it is 1533. So now what is addition of digits of n? 1 plus 5 plus 3 plus 3. And that is equal to 6 plus 9, which is 15. So option B. Okay. So now let's move on to the next question. What is the probability that integer in the set is divisible by 2 and not divisible by 3? Okay, so our sample space is what? All the numbers which are divisible by 2. Okay, so number divisible by 2 is okay. Actually our set is this 1 to 100. Okay, now probability of it being divisible by 2 is what? Half, because there are exactly half even numbers and half odd numbers. Okay, and probability that it is divisible by 2 but not divisible by 3. It means what? Numbers divisible by 2 minus numbers divisible by 6. So let us find out. So there are 50 numbers divisible by div 2. How? 2 dot 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 100. So this is what? 1 to 50. So there are 50 numbers. Now divisible by 6, starting number is 6 and it goes on till what? 96. So 1 to 16. So there are 16 numbers. So 50 minus 16 is how much? 34. 4. Correct. So there are 34 numbers which are divisible by 2 but not divisible by 3. So getting a number divisible by 2 is half into getting a number which is divisible by 2 but not divisible by 3 will be what? 34 by 50. Okay. So this will be okay. So did we miss anything? No. So actually we did not miss anything. Okay. It is correct. So this is what? 34 by 100, which is also equal to 17 by 50. So what is our option? Our option is C. So here what we had to do is first like we had to multiply the probabilities. So first probability is what? You have to get a number which is divisible by 2. So P of divisible by 2 into, now that number is not it is divisible by 2 but it is not divisible by 3. So this probability we have to find. So this probability is what we have to find. So this probability is 34 by 100. This is half. So our answer is what? 17 by 50. Okay. So moving on to the next question. When is unit digit of 13 to the power of 2003? What is the unit digit? Okay. So unit digit. So whenever you have to find unit digit of a number, then what we will do? We take n mod 10. Correct. So now 13 is congruent to what? 3 mod 10. Correct. So 13 square is congruent to what? 3 square is congruent to 9 mod 10. And we know cyclic modulation, like what is remaining. So if it is 9 mod 10, I can say it is same as minus 1 to the minus 1 mod 10. So 13 square is congruent to minus 1 mod 10. So 13 square to the power of, let's say, 1001 will be congruent to minus 1 to the power of 1001, which is congruent to minus 1 mod 10. Correct. Okay. So what do we have? We have 13 to the power of 2002 is congruent to minus 1 mod 10. So 13 to the power of 2003 will be congruent to minus 1 into 3, which is minus 3 mod 10. Okay. And minus 3 can be written as what? Plus 7. So when 10 divides 13 to the power of 2003, what is the remainder? The remainder is 7. Okay. Now this question can be done by another method as well. What is the method? This question I can write as 10 plus 3 to the power of 2003. Now if I open it using binomial expansion, what is binomial expansion? A plus b to the power of n is equal to a to the power of n plus n choose 1 a to the power of n minus 1 b plus dot 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 plus n choose n minus 1 a to the power of 1 b to the power of n minus 1 plus b to the power of n. Yeah. So here we can write it as 10 to the power of n plus nc1, so 10 to the power of 2003 plus 2003 choose 1, 10 to the power 2002 into 3 plus dot 2003 choose 2002, 10 into what? 3 to the power 2002 plus 3 to the power 2003. Yeah. So all these numbers will be divisible by 10. Okay. So we just have to find what is the remainder when 10 divides this. So what is the remainder when 3 to the power 2003 is 10 divides this. Okay. So here again we will have to do, so basically we simplified it to 13 to the power 2003 is same as 3 to the power 2003, which could be easily done by mod as well, and this answer we know it will come as 7. Okay, so let's move on to the next question. Let n be a 5-digit number. Okay, let n be a 5-digit number and q and r be quotient and remainder respectively when n is divided by 100. So when n is divided by so when 100 divides n, we have q and r. So I can write n as 100 q plus r. Okay. For how many values of n q plus r 11 divides q plus r? For how many values of n? So we have been given n is equal to 100 times q plus r and 11 divides q plus r. Okay. So what can we do here? So one way is I can think of 11 divides 99q, correct, and 11 divides q plus r as well. So if we combine these, what will we get? We will get that 11 divides 100q plus r. This is same as 11 dividing n. So 11 divides our n. So we have to find all the 5-digit numbers divisible by 11. So first such number is what? 10010, and last such number is how much? 99999. It is there. So this 9 plus this 9. So if I make this 0, yeah, so this will be my last number which is divisible by 11. Correct. So what is this thing? 11 nines are 99, 11 ones are 0. Then 11 nines are 99, zeros are so 9009 into 11, if we do 909 basically 99009. Yes, so 909. So we have 909 this part and 0. So from 910 to 9090, how many numbers are there? So 9090 minus 910 plus 1. So that is how much? Minus 910. So 8 minus 9. 1 8 0 plus 1. So it is 8181. So how many values of n are there such that it is the given condition is satisfied? Our answer is what? 8181. Okay. So let's move on to the next question. 6-digit positive integers. So 6 distinct positive integers are chosen at random between 1 and 2006. Okay, so our set is 1, 2, 3, 4 and it is till 2006. Okay, sorry, this will be, yeah. What is the probability that some pair of these integers, so we have to form a pair of a comma b such that difference is a multiple of 5. So 5 divides a minus b. Okay. So let's see how we can do this question. So 5 is dividing a minus b. So I can say ki a minus b is congruent to 0 mod 5. Correct. Now what all combinations can we make? Okay, let's see. So we can one of them is a is congruent to b mod 5. Okay, or a is congruent to b plus 5 mod 5 and so on. So let's see What all combinations are there? One is 0, 1, 2, 3, 4. So if A is this and B is also 0, 1, 2, 3, 4, these are what? 4 cases. Okay. Then is there any other case other than this? If A is anything other, let's say A is 3 mod 4, 3 mod 5, and B is, let's say, 2 mod 5. If this is the case, their subtraction will never be 0 mod 5. Correct? Because these are two distinct integers, so their subtraction is not 0. So this will never result in 0 mod 5. So we will always have to find numbers such that A is congruent to B mod 5. Okay. So now first let us split the given numbers in 0, 1, 2, 3, 4 and 5 mod. So first thing is 0. So for 0 mod 5 we have numbers from 5 to 2005. So 1 to 401. So these are 401 numbers. Okay. Now for 1 it will be what? 6 to 2006. So this is also 1 to 401, which is 401 numbers. For 2 now it will be what? 7. From 7 it will be till 2001 only. Sorry, till 2002. So these are how many numbers? From 1 to 400. So these will be 400 numbers. 3 it will be what? 8 to 2003. Again 400 numbers. Then 4 is what? 9 to 2004. That will be again 400 numbers. So we have this classification of numbers. Now what we will do is we will try to find. So what is the probability that sum of pairs of these integers are differences? Okay. So now from these 0, let's say case 1. So we'll have to make cases. So case 1, A comma B is congruent to 0 mod 5. Okay. So here 0 mod 5 there are how many? 401 numbers. Okay. And we have to form pairs. Now are the pairs ordered or unordered? Sum of the pairs of these integers. So they are unordered pairs. So what are unordered pairs? So ordered and unordered. In ordered pairs 4, 5 and 5, 4 are different. They are not the same. But in unordered 4, 5 is same as 5, 4. Why? Because the order doesn't matter. You just have to choose two numbers. So here also we will be choosing just two numbers. So what is it? 401 choose 2. Now what is 401 choose 2? Let's see, 401 into 400 upon 2, that will be how much? 80200. Okay. Now case 2, A comma B is congruent to 1 mod 5. So 1, there were how many numbers? 401 numbers. So again 401 choose 2, which is 80200. Now for case 3, it will be what? A comma B is congruent to 2 mod 5. So if it is congruent to 2 mod 5, then how many numbers were there? 400. So now answer will be 400 choose 2, which is how much? 400 into 399 by 2 is equal to 200 into 399, which is 399 into 2, 81917. So 79800. Okay. These many choices are there. Okay. So what is the total? total will be 80200. Case 3, case 4 and case 5 will be exactly same. Why? This is case 1, this is case 2 and 3, 4, 5. These will be same because all have what? 400 and here it was 401. So total we will get 802 into 2 plus 3 into 79800. Okay. Now divided by. So this is the total basically. Therefore probability, I'll just write down here only. So probability will be these cases upon how many numbers are there? 1 to 2006, right? So 2006 choose 2, which is how much? 2006 into 2005 upon 2, which is 1003 into 2005. So 1003 into 2005. So this is how much? 1604 plus 798 into 3. 21, 27, 24. So 4932. 2394 into 100 upon this 1003 into 2005. So whatever this big number comes, that will be your answer. So let's just find out. I'll erase this. So what will be this addition? 1604 plus 2394. This will be equal to 8993. So 399800 upon 1003 into 2005, and that is equal to how much? Okay, but let's read the question again. 6 distinct digits. Okay, so now basically we don't have to find these pairs. What we have to find, we have to, like, there are 6 distinct digits. Out of this, what is the probability that sum of the pairs has sum or pair of these integers has a difference? Okay, so now how many are there? How many numbers are there? A, B, C, D, E, F. There are total 6 numbers. But in mod 5, how many distinct mods can be there? 0, 1, 2, 3, 4. There can be only 5 distinct. So whatever this F is, it will be amongst these only, like 1 or 2 or 3 or 4 or 0. So we can pair this F with any one of these to get A comma B such that 5 divides A minus B. So we form literally any group of 6 integers. We will always find 2 integers such that A minus B is divisible by 5. So that's why what is the probability? The probability will be 1. Okay. So that's it for number theory. So I'll see you in the other lectures. Thank you.